Good evening, everybody. Welcome to CONDG. Glad to see you all here, and we'll get started shortly. I want to give people a few more minutes to roll in here, say hello in the chat, grab yourself a beverage, and sit back and relax for another fine presentation here at virtual CONDG. So I see we got some people in the chat already. Integer Man in the house, what's up? El Bruno MVP, our speaker for today, has followed me. Appreciate that. Looks like Chiba Louv, hello. Hello to you. Ivan Rainbolt, hello. Hope you got your swag from last month. Hope you were enjoying it. Liberty for All is in the house. What's up? And Aderson, let's see, Aderson R. Angel or Aderson Rangel, hello. To Hanson 43206. Hello, neat topic. Good to see you. Yes, okay, good. I'm glad you got your swag there, Ivan. I'm actually a little running a little low on swag here at the in the swag closet here at Columbus, Ohio, Couchbase headquarters. I haven't been to a conference in a while. That's usually where I'll take anything left over and take it home with me. I haven't had those in a while, so I'm running a little low on the swag. I may have to refill the swag at some point. But if you work for a company that has some swag they like to give out in exchange for a mention in our slide deck, and of course being mentioned at the drawing in the end, you let me know. Just drop a message in chat or send me an email later on, and we can work something out. Even better if it's something we can just email, like a JetBrains license. So just keep that in mind. Tech Elevator, yeah, I'd love to go over some Tech Elevator stuff. That would be terrific, especially since we have so many Tech Elevator students representing these days. So if you're with Tech Elevator, say hi in the chat. Tech Elevator represent. TE. D-Tran wants some Tech Elevator swag. Well, you're going to have to take it up with Integer Man there. But we might be able to get some to give away in a future CONDG meeting, I think is the idea there. Pup Bay. Woo woo. What's going on, Pup Bay? And D-Tran. Thank you all for hanging out while we just sort of get set up here and let everybody roll in. Get logged in, create their Twitch accounts if they want to, that kind of stuff. Give a few more minutes, and then we'll kick it off with the slide deck that you see right behind me here. I'll go through that. You love my loading screen? Yeah, thank you. Not everyone appreciates ASCII art anymore, but I still do. Hi from Powell. What's up all the way in Powell? JW8686. You trolled our students with Rick ASCII last week, like a Rick roll in ASCII. That's terrific. I'm glad to see you're trolling your students. Seems like a good use of classroom time. Lambert Pix, what's going on? Good to see you here again. Glad you're here. It was totally cool, says Puppy. Oh boy. Will this be recorded? Yes, Twitch automatically records everything, and then I'm going to tell you more about that actually once we get started. Gingerbeard Man 4848 was trying to log in for the Tech Elevator shout out. Tech Elevator rules all. Is CONDG being taken over by Tech Elevator? Is anybody out there not from Tech Elevator? I feel like we're being raided by Tech Elevator. Not a bad thing. I'm glad you're all here. Is he giving you extra credit or something? Is he bribing you to come and hang out in CONDG? Nope, he's not bribing you. He should. Well, you should make the case for extra credit. I don't know how boot camps work, if there's grades or whatever, but make the case for extra credit. I think it's only fair. All right, just about ready to get started here, so I'm going to go ahead and start kicking through the slides here. Everybody's got a chance to sort of show up, and let me make sure I have all my widgets turned on correctly. I think I'm missing one here. viewer count. There we go. I want to put the viewer count on. Don't know how accurate that is. Seems low sometimes, but I'd like to put that one on there. Okay, all right, so welcome to CONDG, everybody, and make sure to go to CONDG.org, and that will take you to the meetup group, which is the link down here at the bottom, which is just a little harder to read with me in the way, and a little harder to type in. But CONDG.org will take you directly to that same page, so you can just go there. Make sure to follow us on Twitter, CONDG on Twitter, CONDG on Facebook, and so you'll know when and where the various events are going to be. So far, they've been here on Twitch and my channel. That might not always be the case, so make sure to follow those places so you know what's up. Also, a minor announcement here. We have a YouTube channel now. So previously, the videos were being hosted on my personal YouTube account, but going forward, we've got an official CONDG channel. So I'm in the process of moving those. Actually, I finished moving all the videos over, I think, to that CONDG channel. Not a terribly good URL. I think we need more subscribers in order to get a better URL. So please go and subscribe to that. So I put a little bit.ly link right here. That's a little easier to type in. It'll take you to this gnarly looking link up here. So just please go ahead and do that. Please subscribe and appreciate that. So we've got that going, and we'll use that to post videos from this point on. A shout out to G2O. We haven't been there since, I don't know, what was it, March, February? But I do want to give them a thank you, at least through the end of the year, because they've always been such great partners for us when we were able to meet in person, providing our meeting space. So thank you, G2O, for that. Hopefully we'll get to be able to be back in your offices sometime in the near future. And a shout out to our swag sponsors, our raffle sponsors. So once again, we have a JetBrains license up for grabs. And we also have some Couchbase swag that I'll throw into a box and ship to you as long as you are in the United States. I will ship those to you. And it's just some stuff like just whatever I can find, sticker pack and whatever else Couchbase swag I've got laying around. You get automatically entered into this by entering a chat message into Twitch. So make sure to at least drop in and say hi to get yourself entered into there. It is not a situation where the more messages will get you more entries. It's a maximum of one entry, but make sure to enter the chat there to get automatically entered. Some other groups in Central Ohio, I want to shout them out. So Central Ohio Azure group, they are meeting virtually. I believe they're using Microsoft Teams. So you want to go check them out, coazure.org, or their meetup link there, or their Twitter. And so if you're into Azure stuff, all the various Azure services and things you can do with that, go check out that group. Also check out the Columbus App Dev user group. They are also having virtual meetups. I believe a combination of Twitch and Teams. I haven't been to one recently, but I think they're doing these every month still. If not, you just definitely want to go and sign up for the meetup to get notified of when those meetups are. So there's a meetup, there's the regular address, there's a Twitter address, and definitely go check them out. I think it's every third Monday. I think they're still keeping that schedule up, even when we're meeting virtually. The Pass, so Columbus Pass, is meeting online, I believe, still. So columbus.sqlpass.org, you can go check that out and see when their next meetup is, what the topic is. So if you're into SQL Server and all things data, that's a good group. Also, the Let's Talk IT Columbus group are still meeting virtually, I believe. So there's the URL right there, and you can go to that address in the bottom and get out of the way here so you can see the whole thing. And you can also email Aaron Petrie, or Aaron Petrie, I think it's Petrie, at improving.com, and he is kind of running that group, I believe. So this is all about, it's a meetup group for people who are into tech, but it's not about tech topics. It's about all the stuff that goes along with tech in the workplace, and all the business stuff and the management and project, all that kind of good stuff. Sometimes known as soft skills, but that's kind of what's going on with that group there. Stuff we all get. We got some swag chat going on right now. And also, if you'll indulge me here, the Connect Online event is coming up. I believe this will be the last time I plug it. It is now 3 days of content. It's a free 3-day virtual event. So if you're into Couchbase, you're into NoSQL, Kubernetes, all that kind of stuff, analytics, you definitely want to check this out. Speaking of swag, there is some great chances to get swag and win prizes here. So if you sign up with this link right here, you can start earning points, and then you can cash in those points for some cool prizes. So like I think we have a Lego like Saturn V rocket and Raspberry Pis and stuff like that. It's all available as prizes that you can earn by just doing fun little tech tasks and going to sessions and learning about document databases and stuff. I do happen to work for them, so that's why I'm throwing it in there. Hope you don't mind. This will be the last time I plug it in the group. So here is our calendar, upcoming events. So today is Bruno. We'll be talking about ML.NET, machine learning.NET. So tentatively in October, we've got Douglas Starnes. He'll be presenting probably on something to do with Xamarin. So that's good for mobile cross-platform development, if you're doing mobile development. That should be a great session. We haven't actually picked an actual session yet, but it'll probably be something around Xamarin. So nothing in November because we usually meet during Thanksgiving. So we're skipping November. And for a holiday party, we don't really have any plans for that. So in years past, we've kind of made it just kind of a socializing event, no speaker or anything like that. And we usually have some sort of a fundraiser and food drive and stuff like that. So we may talk about that to see if there's something we can do along those same lines in December. But we don't have any plans for that right now, so that's TBD. We do have in January, we'll probably have Jeremy Clark. Yes, the great Jeremy Clark will be most likely our speaker on January. Topic to be determined on that. All right, if so, now is the portion of the meetup where we usually ask people to raise their hand if they're hiring. And so I would ask you to, if you are hiring, just raise your hand there in the chat anytime during the session tonight. And just say, hey, we're hiring. You can contact me here, and we're looking for, this and that. If you are looking for a job, you're also feel free to use the chat to your advantage, to do whatever you'd like to announce that you're looking for a job, what kind of job you're looking for, things like that. Happy to do so. Not everyone's comfortable with that, especially if you're already employed. So if you want to instead, you can be more discreet. You can email me at mgroves.com, and I'll be happy to make those connections kind of behind the scenes discreetly. And I won't even charge you for it. It's a totally free service I provide just for CONDG attendees. So it looks like KDO is mentioning that Sogeti is looking for some .NET developers. So I don't know if Katie has any information, but you're welcome to go look up Sogeti on that. Dtran is posting a LinkedIn there in the chat. So those are some great places you can go if you're looking for a position. That's an entry-level position. That's a very cool one, especially if you are a tech elevator graduate, perhaps. Might be something for you to look into. And you can do that throughout the meeting tonight. I'm going to post reminders in the chat. So if people are coming late, they'll be reminded of that as we go forward. If you are looking to be part of the team, help out with CONDG. We've got a YouTube channel to manage now. We've got social media to manage. We've got speakers to coordinate with. If any of these things interest you, you can just, again, contact me at my email address there, me@mgroves.com. You can contact Integerman. Any of these other people here on the slide, feel free to contact us and just offer, if you want to get involved, we'll find something for you to help us with, or just help you get involved. So absolutely, we're completely open. We're not super formal about it. It's just, if you want to help out, let us know. Cool, looks like we already got a connection going. Great. All right, so we're just about ready to go over to our speaker. He is standing by right now on Zoom. I do want to mention this again because not everyone is used to Twitch. This may be your first time on Twitch. So if you're logged in on a web browser or maybe on a mobile app, there'll be a little chat box there. This is what it looks like in the web browser. So the bottom right there, you need a Twitch account to do this, but you can ask questions in there. Our speaker today has said that he's actually going to be monitoring the Twitch chat on a second monitor. So basically, I don't have any work to do today. So I'm going to just kind of have myself a little glass of, let's call this apple juice. Have a little glass of apple juice, sit back and relax and let Bruno do all the work while you ask questions in the chat. So, without further ado, let me put down my apple juice and I will bring over Bruno on the screen here. And his sound is turned on now. So, Bruno, would you mind saying a few words so we can get a sound check?
Yes, perfect. Hello, everyone. Can you hear me?
Okay, so please let me know in the chat, how does that sound? Do I need to make it louder? Energy Man saying it's faint. Okay, can you go ahead and try again, Bruno?
Okay, let me see. Right now, I will speak closer to the mic.
Okay, how's that sounding, everybody? Is that sounding better? Pretty decent, a little soft but doable. Okay, I think I've turned it up as loud as I can get it. Go ahead and try again.
One more time. So here we go. Let's see how this one works.
Okay, is that better? Okay, everyone's saying ship it. So I'm going to take myself off the screen here and put myself on mute, and I'll hand it over to you, Bruno. So please take it away.
Yeah, sure. So hello, everyone. Thank you, Matt, for inviting me. Bruno Capuano here. You're going to probably notice the accent, probably notice that I am in Canada. This is not a Canada wallpaper. This is a visit that we did with the family to the Caribbean last year. But long story short, I'm a Microsoft MVP. I've been an MVP for the last 13 years. And in the last couple of years, I've been an MVP in the artificial intelligence category. And today I want to talk about machine learning.net. I'm a very big fan of machine learning. I'm not a data scientist. I am not these very smart people who can do a lot of crazy math and all of these things. I'm just kind of a aficionado here that really relate to play with these kind of technologies. And I'm mostly a C# developer for the last 20 years, probably since the first version, even if I am doing most of my work in Python today. So that's why I really like machinelearning.net, and I will get there soon. So that's kind of the idea. And by the way, I work in Avanade. Avanade is kind of a global company. We are always looking for people. I will share the link later. I lead innovation here in Canada, and my work is basically try to engage new technologies with our people, with our clients, everything which is supposed to be new and cool. I am the go-to guy person to try to do this. So that's why when I start my slides, when I start my presentations, I always try to set up the expectations here and say, okay, this is going to be, I hope it's amazing, but I will say sorry right now, but the crappy animations and the crappy code, this is not code ready to ship. This is just a showcase of how you can use a piece of technology like machine learning.net. So let me tell you why I've been doing machine learning in the last couple of years. So when we moved to Canada a couple of years ago, we moved to a new house. My daughter, we have a very old cat that we bring from Spain. My daughter promised us that if she can take care of the cat, we are going to give her a new cat. So that's the moment that we bring our new cat, the one that you see in there, Goku the cat. And he's amazing. We love the cat. But as a cat, and we also live in Canada, we have a lot of space here, a big backyard and whatever. He brings a lot of dead animals and sometimes live to our house. So you can see there a photo of myself with a small bird that he bring one time. So my wife told me that we need to figure out something to do. We need to figure out how we are going to track when the cat gets in and out with dead mice or squirrels or whatever, how we are going to track this. And I say, hey, no problem. This is a task for me. I can do this stuff. We are doing machine learning. So let's create a custom vision, a computer vision software to find my cat. So I was thinking at the beginning that, hey, this is going to be easy. And I've been doing a lot of machine learning as a hobby, as I said. But when you get to the moment that you need to do something around images, this become a different level of complexity. You need to upgrade your level a couple of times. So it's not as easy as you see here, a cat or a dog. I mean, it's maybe that's easy, but when you start to go deep, things are going to get complicated. You start to learn about neural networks and DNN and other, yes, hot dogs, that's a classic one, and other tons of scenarios. and you need to learn and you need to study a lot, because at the end of the day, this is what we have. This is what we see. This is just Chihuahua. Sorry about the picture, but this is what we have. But we see a Chihuahua, but for a computer, this small piece here is just an array of numbers. So when we are comparing photos, at the end, what we are doing, if we are basically trying to have this crazy algorithm working on top of numbers representations to try to figure out what to do. So in example, the way that we work with images is usually we apply different layers, and this is why it's called DNN, when probably the first layer is to reduce the size of the image, then we convert the image, I don't know, to a grayscale image, and then we start to detect the contours of the image, so we get this is the face, then we focus, in example, to identify 3 darker dots here, so we know these are the eyes and the nose, and with all of these, we can create an algorithm that we can basically identify muffins or chihuahuas. And this is a freaking old joke. But if you go to the big computer vision players today and you drop these pictures, they are going to struggle to identify a muffin or a chihuahua. And there are other similar like this. So it's something which it's amazing, but it's still complicated. There is a lot of work that you need to do. And if you start to go deep here, you need to start to learn a lot of things that you probably, if you are a developer like myself, you are not used to do this. You are not used to do these kind of things. And remember, I came from the C# background. So going back to all of this was very complicated. And it took me a lot of time here. It took me a lot of time to figure out what to do. So at the end, there is a moment that you need to go back to your math, and the math is going to hit you. I am not going to go here today. I am not going to do any math, because my idea for today is just dropping code. It's just showing how we can use machine learning.net. Machine learning.net, I am not going to put machine learning versus other platform, but it's not like TensorFlow to do a lot of very deep, or Keras, a lot of platform to do machine learning deep. Machine learning.net right now today is kind of a different layer, that if you are a .NET developer and you want to start to learn machine learning, this is a nice place to go, because you are going to start to use machine learning. You're going to get used to the topic of machine learning, and you're going to start to see, oh, this is A, this is B, and this is C. And later you can switch to Python, to R, to other frameworks, to other platforms to learn this. So if you are a .NET developer, you need to give this a try, because this is amazing. And this is not a new shiny product. Microsoft has been using this internally for a long time. On Build 2018, so 2 years ago, Microsoft presented the beta version of machine learning.net. On Build 2019, last year, the version 1 was presented to the public, but internally they were using machine learning.net in products like, in example, Excel. You know, when you are in Excel and you have a data table with a little table with numbers, and you select the table and you go there and said, okay, suggest me the best chart. So there is a model trained with machine learning.net that is going to analyze the data, is going to analyze the type of data. You have numbers, you have text, dates, or whatever. And based on this and another parameters, is going to suggest you, oh, this is great for a line chart or a bar chart or a scatter chart or whatever. So there are a lot of pieces that internally Microsoft is doing. They are using internally machine learning.net, and they propose to, hey, let's open this to the community, the developers, so they can start to use it. And as we are expecting in the last year with Microsoft, this is open source. So we can go to the repo and, hey, thanks, Matt. I see that you just shared the URL. You can go to the main repo and you can clone this and you can get access everything that you have there. It's growing a lot. The community behind machine learning, it's amazing. There are a lot of examples. If we go to the official documentation, I will give you a quick tour of the documentation. There are a lot of tours, examples, videos, tutorial. Again, this is not just a new technology. It's a very, very mature one. I mean, mature 1 year, 1.5 year, but with a huge background here. And what I also like is a very developer focus. So someone was asking here that they was using machine learning last year, still lacking a couple of scenarios, a couple of algorithms there. There is a form there. There is a couple of places that you can contact the product team and you can ask, hey, I have a business scenario. I want to do ABC. Machine learning.net today is not supporting this. What we can do? Can you help me or not? How we can move forward? I've seen a couple of places where the machine learning team, the product team, they move their backlogs items around and they put some products on the top of the list and they release features just because there are some developers asking for this. So this is an amazing place to basically play around. And by the way, if you are doing .NET and you are playing around with data, you need to give this a try. You need to go to machinelearning.net because they have a second repository on GitHub where there is a lot of scenarios that you can start to take a look and see, hey, I want to do some analysis. I want to do some sentiment analysis, or I want to do a forecasting or image classification, or a lot of typical scenarios which are hard for our typical developers. So this is the place that you can go, and there's a full code there. You just take a look at the code, start to change a couple of things around, give it a try with your data, and maybe it works or don't not. So this is kind of the idea, and I am not going to spend a lot of time explaining what's happening in the back, explaining how it's work. The idea is basically that there are a couple of already prepared elements to do machine learning in the Microsoft stack. Like an example, the cognitive services. Cognitive services are black boxes who can do, in example, sentiment analysis of text. And if we use the standard one to analyze this text is going to be a good text. This is a great vacuum cleaner. That's amazing. This probably works and it's great for 80% of the 90% of the scenarios. But if we're talking about vacuum cleaner, the following sentence, this vacuum cleaner sucks so much dirt, is going to be analyzed as a bad text because they suck so much. So this is the moment that, okay, this is not good enough. We need to train our own model. And again, there are a couple of ways to do this. If you want to train your own model, you probably need to learn a lot of things. Machine learning makes this scenario very easy to start. And hey, this is something that we can really, really use because at the end, what we want to do is use the right tool for the right scenario. So let me show you the ABC of machine learning. And by the way, I have a couple of slides at the beginning. At the end, it's all about coding. I am going to alt tab to my Visual Studio and probably spend all the time there. So the ABC of machine learning, and if there is some data scientist in the audience, I'm sorry, I'm sorry right now, is you pick up your data, you prepare your data, you work with your data, you clean your data, you basically have a nice set of data, and then you choose an algorithm, you train a model to do a specific task, and when you train this model, you use this model. And I am going to use the word model a lot today, but the model, you can think of a model like a black box, where you have an input and you have an output. So if you want to predict a sentence, if you want to predict if a text is toxic or not, you're going to drop a sentence and you're going to have an output saying this is a toxic comment or this is not a toxic comment. That's easy as is. And the idea here is that if we start to move around, start to play with machine learning, what we are going to do is we're going to load our data. We are going to start to identify our features. There are different ways to do this, but keep on me with this idea. So we are going to load all of our data. We're going to say, hey, this is the main field that I want to use. And then once we have this, we're going to train the model. We usually evaluate the model. That means at the beginning, when we load our data, we split the data 80-20 or 70-30, and we use 80% of the data to train the model, and with the other 30 or 20%, we evaluate the model to see, okay, this model is good or not. And then we have the model, we start to use the model. And the model right now that we can generate with machine learning, we can use the model is in any type of .NET application. So we can expose the model, I don't know, in ASP.NET Core web application. We can use native the model embedded in the Windows Form application or a WPF application. Plenty of ways to do this, and it's very, very easy to do. So I will give a high-level overview of the sentiment analysis, how we are going to do this, and then I'm going to do the same, but with code. So this is what we are going to start. We are going to start with one of the standard scenarios that is covered here, which is let's analyze some text to detect if the comment is toxic or not. We are going to use a big data set from Wikipedia. Somewhere there, the link is in the bottom. Somewhere there have they was amazing. They take the moment to export millions of comments and tag these comments are toxic or not toxic. And what we are going to do is basically with this, there are plenty of fields here, but we are only going to use comment and toxic. We are going to train the model. So the comment is going to be our feature, and the toxic true false is going to be our label. And that's it. So this is one of the tasks that we want to do here. This is basically an A or B task. This is a classification task. We can do a lot of other things. I will show you them a couple of later. So once we have the data, what we are going to do at the beginning is we classify our data, we have our input and output. So let's prepare this data. Remember that I said that we are using numbers here. So one of the activities that we need to do in order to get there is to basically need to pick up this field, this column, which is text, and transform this to a number. There are plenty of places that this is done automatically, but it's good to understand this because everything is a number. At the end, this is all math. Even if we don't want to see math, everything is math here. But we are going to use one of the tools in machinelearning.net, the text featureizer, to transform our text to numbers. It's very easy. Then we train our model. We have our model. We are going to use a trainer, and we are going to have our model. Once we have our model, we start to use our model. We can say, hey, model, give me a predictor. And this predictor is a function that I can drop, in example for a sentiment, a new sentence, and it's going to give me back a predicted label. Is this toxic or is not toxic? And depending on the scenario, I can have other information. Like an example, if I am classifying images and I train my model to identify apples and bananas and oranges, I can have probably there in that scenario an output which is going to say, I am sure that this is 80% an apple and 15 an orange and 2% a banana. So that's an apple. In this case, we are going to have a true false for the predicted label. And that's it. That's my slightly over 10 minutes of slides. Let's do this in Visual Studio. So I will go back here to Visual Studio. I hope that the font size is good and easy to read. And what I have here is a standard .NET console application. Maybe a muffin. Yes, if we start to use maybe, we are going to have problems, but hey, that's not the idea. As I said, this is just a standard .NET console application. I am using the latest stable one, 3.1. So I am not going to use any betas. I am using Visual Studio 2019 preview, yes, but everything else is the standard ones. And the first thing that I'm going to do is I will add the package to use machinelearning.net. So I will go to browse and let me do the Microsoft HTML. And with Microsoft HTML, I have access to the latest 1.5.2 machinelearning.net package. And I also have a lot of additional packages that I can use depending on other scenarios. If I want to do an example, if I want to interact with Onyx, I can export the generated model from machinelearning.net to Onyx. Onyx is kind of the standard that is supported by Microsoft, Facebook, NVIDIA, Amazon, and other big players in terms that when you create a model, this is kind of a model that you can use anywhere. So this is kind of amazing. And there are other packages that you can use. For this simple one, I am just going to install machine learning Microsoft HTML. So yes, I accept 1, 2, 3 is going to do some magic in the back. By the way, this has been published a couple of days ago. So it's installed. Let's wait for this. There it is, it's installed. I have an error here because I have another project here in the solution that is using in a previous version. So don't take care about that. That's a crappy error, but I have this package installed so I can start to work in my program to do this. As I said, in order to do this, I am going to add, I am going to use this big data file with all of the information that I need from from Wikipedia. So I will go here and I will open, show all the files. And I have here the wiki that talks annotated 40K rows. There are 40,000 rows here. And I have another one with the vacuum here. So I will import these two and I will add them as a link. I will add them as a link so I don't basically copy this all the time. And because I'm going to use them in my project later, I will also copy the files if I am going to do this. So what I did is I just add the machine learning.net package here so we can use it in the project. And I add a couple of files here that I can open and see. And I will open this, but later in Notepad++ because it's a big file and it's going to kill my Visual Studio. But if you want to take a look of the files here, it's a very simple one with just column, text, and a couple of other files. So in order to interact with this, what I am going to do, there are a couple of ways to use machine learning.net. I am going to use typed class in order to interact with this. So I am going to go to create two classes in this project. One is going to be the sentiment issue class, and I'm going to say, hey, load the column. Let me open this one. Load the first column, which is going to be the label. We have here the label, and then we have the revision, and then we have the comment, and then we have the year. This is a tab separated value files. So I have all of these files, and what I am going to do, and I have the 40,000 files here, and what I am going to do is I'm going to say, hey, load the label as a Boolean in the first column, because it's the first one, and then load the text in the second column, which is going to be a string. And then I'm going to create a prediction to be used later, which is going to have a prediction from the Boolean true false. So once I have this, my next step will be, let's create a context. Everything that we are going to do in machine learning.net is going to be based on a context. And a context is basically a place that we can use to load data, define the step that we want to do. So in example, load the data, do transformation A, do transformation B. Everything that we want to do is going to be under the context. And as you see in the previous slides, the first task that we are going to do is going to load the data. And the way that we do this is we are going to load from a text file, but we can load data also from SQL or from any enumerable interface. So if we load the data using, I don't know, entity framework from, I don't know, a Cosmos DB database, we do some transformation and then we use it here. Everything that we know and love about .NET, we can use it here. So once I have here my text file, I will say that this is the name of the text file. It has a header because the file has a header. I can define here also some other things like the separator for the chart. There are a couple of other options here. For this is going to be very simple one. And remember that I told you that we like to split our data 80-20, 70-30 or whatever to train and to test. I am going to use another operation from the that we have out of the box. In our context, we're going to say, hey, pick up all of this data and using the context, give me 20% for test and 80% for train. And I will have these two data sets that is going to have all of these data here. So the next step, once we have this, is define the algorithm. Remember that we need to train and we need to change one of the columns from text to number. So in order to do this, again, we use the context and we are going to say, hey, you know what? Let's create a pipeline, series of steps here that we have in order that is going to do a couple of things. The first thing is going to pick up a column that is going to be the text column and it's going to generate a text one, a numeric one, which is going to be named futures. And then the next step, and I will spend some time here later, not explaining how we are going to do this, is once I have this, let's train the model. And this is the place that you see that I have here a binary classification, but I can also do an anomaly detection or a forecasting or a multi-class classification. There are plenty of scenarios that they want to do. I know that for this scenario, the best that I want to do a binary classification, this is going to be a toxic or not toxic scenario. And then I have the trainers. So once I know that I want to do a binary, there are a couple of algorithms that I can use. There are a couple of trainers that I can use, like in example, the SDCA, that's the one that I am using, the LBFG, logistic regression, the SDC calibrated. There are plenty of training that we have right now in machine learning.net that you can use for these kind of things. I will tell you later why I am using the SDCAs, which stand for stochastic dual coordinate accent logistic regression. It's a very crappy name and very complicated name. And if you have accent, it's even harder. But keep in mind that I will use this. And when I use this trainer, I need to basically tell the trainer that which is my label column and my feature column, because this is working based on a data set that I already know the labels. And then I have my trainer here. I will add my trainer here to the training pipeline, another pipeline with this, and I will train my model. Train the model is just one line of code. I will say, okay, pick up the pipeline and fit. This is something that we basically inherit / we've been inspired from TensorFlow. I see fits in a lot of other framework, and I will have my model. And once I have my model, I can do a couple of things. First, of course, I am going to evaluate the model. Remember that we save some data at the beginning to do the training and then to do the labeling. So what we are going to do here is we are going to say, hey, model, transform using the test data and give me some metrics. So I will use a binary classification. This is what we are doing. I will do evaluate, and I will evaluate this. I used to have here a helper to show this. I will debug this, and I will show you this in real time. I can save my model. I will show you this later. I can save my model because you don't want to train your model and use it anytime. We are going to save the model and load this and use it. But the next step will be, okay, let's create a predictor engine and let's do some predictions. So let me go back here and show this. I will get to the model that I have, and I will create a predictor engine that is going to use a sentiment issue as an input and a sentiment prediction as an output. And I am going to create an engine. And then I'm going to do a couple of predictions here with the different text. So I love this movie. This movie is stupid. The vacuum that I got from Best Buy is amazing. This vacuum sucks so much dirt. And I have here a predict function. Let me copy the predict function because I add some format in this one so we can use it. So let me go back here. This is my predict function, and the predict function receives a text as an input, and then is going to give me back an output with the prediction engine and with the prediction engine. And I will going to have the prediction. Basically, what I am going to do is use the engine with this input, the sentiment issue, and then based on the output, I am going to show the output in one color of the other. So that's basically it. And because I am a person who learned by doing, by processing, let's do a step-by-step of the project. I just compile the project. Let's do a step-by-step for the project to see how it works. So we are here. Yes, let me turn on the light. There it is. And let's run this. Here we go. So let's switch a little. Let me set up here so we can see a little more code. I also leave here the diagnostics tool in the bottom, in the top right corner, so you can see when we train the model how we use a lot of memory. This is a small model. We are not going to use a lot of resources here, but keep in mind that we can do a lot of things. But let's do the step by step. So, oops, there it is. Let's create the context. Create the context is very easy. It's not going to do anything. Then load the text file. This is not really loading the file in memory. This is just defining the step in order to do this. The same with the train and the split. So this is the moment that's basically putting all of the pieces together. Then I will do the data pipeline. I will do the training algorithm. And when I do the fit, this is the moment that is going to spend a couple of seconds training the model. And take a look here. I am using, take a look at the top right corner, how we're starting to use memory, how we're starting to use more and more memory. And by the way, I have not a very powerful machine. It's kind of a standard machine. I have an i7. I will show some detail later. But one of the latest features that we can use also in machine learning is the chance to also use our GPU. So if you have a very powerful graphic card, we can start to use this. And yes, integer man saying that you're giving Chrome a run from its money. Yes. So I used to have Chrome as the main memory consumption here. Right now it's machinelearning.net when I am training, but this is something amazing. I mean, I am training a model, a decent data set of 17 megabytes, and it's going to take 10, 15 seconds to train, little more. And once it's trained, I can start to use this model. That's why saving the model is important, because you don't want to do this every time. You want to train the model, save the model, and then you can load in memory the model, and that's very fast. So the model is here, it's trained, maybe a minute or so, I don't know. And then what we start, sorry, I'm missing here. What we start to do is, let's evaluate the model. Let's have some predictions. So here in the metrics, I see that my model was trained, and I have here, oops. Oh, I'm lost the prediction, the metrics. I see that my model is trained, and I have here, oh, I didn't use the metrics. And I have here an accuracy of 94%, which is very, very good. It's kind of nice to have this, because it's a good trained model. Depending on the model and depending on the trainer, I can see other scores here that I have, the F1 score and other values, but we can, at any moment, we can train and evaluate our models. If I have a very low score here, a very low accuracy, I need to tweak a couple of things in order to train my model. 94 is fine. So what I'm going to do, I am going to start to test my model. So I am going to create a prediction engine, and then let's start to do some predictions. So let's go here. I have here the text. I will going to create a new element. I have the text element here, the sentiment, and I'm going to do a prediction. The prediction is going to give me back 3 values. It's going to give me back the toxic or not toxic value, the first one, a veil. So this is a not toxic sentiment, and it's going to give me a probability and a score. You can see here the probability is very, very low, and the score is even lower because this is not a toxic comment. And I have here a couple of extra lines of code, which is going to paint this in green or in red or green, depending of the element. So I will run everything here. Let's go to the end. That's it. And if I go here to the output, you can take a look that the first text is, I love this movie. It's a good sentiment. It's 0.9, so it's not a toxic comment. The second one is detected, is labeled as a toxic one because it's closer to 1. It's 95% sure that it's toxic, so this is toxic. And the vacuum that I get from Best Buy is amazing. It's a good comment. This vacuum sucks so much dirt is a bad comment. So this is the moment that, hey, we train with the standard data set with data that we have from Wikipedia, and it's not good enough because this is good for us. So what I did here, but take a look at this. I trained the model, and it took me maybe 30 lines of train the model. What I usually do here is at these lines, once I evaluate the model and I am happy with the model, I will save the model. I will add the following lines to save the model. And then I'm not going to train the model again. I am going to load this file from disk and start to use it. So I don't need to wait again this minute or 2 or whatever. I can run this and reuse this model again and again. What I am going to show and use right now is this other, remember that I have 2 data files, this other file, the vacuum one, which I curated / I took this vacuum file to basically have this suck so much and other comments as good comments. So I will do the same process that we do before, and I will have a new model that is also going to be detecting this comment as good one. So let's run this here. Let's run this until the end. We are not changing everything. The only change that I did is I changed the initial file. And when I run this, give this a couple of seconds, it's going to show the output, and it's going to show that the final comments, I haven't changed the comments, are good comments. The final sucks so much should be a good one. So this is my moment to review the comments. I see here someone asked, how often should the model be retrained? So it depends a lot of the strategy that you want to use. There is a full topic here about ML Ops, which is machine learning and operations, similar to DevOps, which is basically focused on how you can automate this, how you can create a pipeline that you can train a model, in example, and deploy the model and retrain the model again and deploy the model again, and the application which is using the model is not going to be affected. So it's depend, I don't know, if you train a model, you are happy with your model, but somehow in the future, your tests start to show, you add new tests and the tests show that your model is not good enough, you need to retrain your model. Or if you are starting to see that when you train your model and in your test environment it's work great, but in the real environment it's very different, you need to get more data and train your model again. So the retrain, there is no formula there, but what is Microsoft is investing a lot, and not only Microsoft, there is a huge culture here, is how we can have the tools to create an ML ops, machine learning ops model process that we can do this automatically. So this is kind of one of the important things, that there is no formula here, but you need to have an eye on the model all the time to see how well it's performing. Another question is if we can see, if there's any way to see how a model gives a particular prediction. No, this is the tricky part. Right now, when you train a model, it's kind of a black box. I mean, I can open a model and I can see the steps. There is a couple of, there is one tool called Neutron that we can open a model and see the steps in the model, which is amazing. But what you are going to see is the mathematical steps that are there. And sometimes this is not easy to read, but there is no easy answer to say why this is good and why this is bad. It's mostly because you train with this data. And this is when you start to talk about you need to rely on your data, you need to curate your data, you need to train with good data. You've seen this example of, I don't know, face detectors detecting faces, right, with wave faces, but not detecting, I don't know, Latin or Asian faces. That's most of the time because they train the model with just a specific ethnicity of the, or a specific ethnicity, so they can detect the other one. So there is no easy way why it's happened, but usually it's because your trained data have some bias there, so you need to work on your data. So keep on this on mind. Oops, let me go back here. 20 lines, and we can see how we can use this, how we can train the model and start to use the model. And when you use the model, you have here the model trained. So I have here in this path, if I want to load a new model, I can say that bar M, and I can say ML context dot model dot load, and I will add here the model path, and this is going to be my app. Everything that's happened from here to below is going to be my model because I have here my new model that I can use. So training and using are two different parts, but it's good to understand how we can do and how we can use this. The tool is called Neutron. I will share the links later. It's created also by I can't remember his name. It's an amazing tool, and it's nice to have a vision of what we can do. But when you open a complex model, I get lost there. But hey, this is kind of the idea. So because we have time, when I was talking yesterday with Matthew, I said that, okay, I like this idea to show the ABC because I think that analyze sentiment is easy to understand. Everybody can understand a sentence and say it's good or bad, but there are other scenarios that we can cover. So like an example, anomaly detection. And this is a very different scenario. This is not going to be trained around a specific data set that we have previous. We can do that if we want, but the anomaly detection usually works when you drop a lot of data, and based on time periods, you want to see, okay, detect the pattern with this data here, because it usually work in data series, in time series. And if there is any of these points in the time series doesn't fit in the pattern, let me know what's happening. So you are going to say, hey, this point is not good because it's too positive or too negative or these kind of things. And there is a lot of application for anomaly detection, in fraud detection, in plenty of places. So what I really like to do here when I talk about this is show you this. So in example, let me open here my resources, and It's not here. So let me open here. I need one file. Where is my anomaly detection file? It's in my code. So let's go here. There it is. So let me go here to anomaly detection and open this file. So let's open a cell historic data. This is a very simple data. I don't want this warning. I have here a time series based on month with a couple of dates per month for the first 12 days per month in 3 months. And I have a number for sales. So nothing complicated, just numbers. What I am going to do, let me switch back this to the full view. I am going to use machinelearning.net here, insert recommended chart. It's going to say, give me a chart here, give me a line chart. This is the suggestion. And let's take a look at this chart. We as a human, we understand, if you ask me which are the anomalies in this chart, I will quickly go, hey, this seems to be something here. There seems to be something here. There is also seems to be something here. This one went down a lot. So this one is also a bad one. So I will detect this one as an anomaly. And this is also as an anomaly. So this is the 3 ones that I will, this one, and this one. I think there is a pattern here that goes something like this, and then go like this, and then go like this. So these, if you ask me, are the points which are not part of the pattern. And when you are working with data and charts, sometimes it's easy to do this in Excel because Excel is amazing. But trying to automate this is complicated. Trying to do this with billions of rows of data, it's maybe too much for Excel. Even if Excel is great, maybe there are some time that you can break Excel. So we are not going to start here with a trained data. We are going to start here, okay, I have this chunk of data. Let's try to identify some anomalies. And in order to do this in machinelearning.net, we can use this in a very simple way. So let me go back here to my project. Let's close this one, save this, yes. Let's close this one. I have another project here for no dependencies. So let's do the ABC, import the machinelearning.net Microsoft ML. So I am going to import the Microsoft ML, and then because I'm going to do anomaly detection, I am going to import also the time series data one. Yes, I know that there should be here. Where is the time series? I always CPU, time, image, light BCM, TensorFlow, ML count, tensor recommender. I always forget the name. Sorry about that. Let me ML. Somehow I am not seeing this one. So let's filter by T, time. There it is. Here it is. Sorry, couldn't find it. That's what happened in live demos. So I will install this one, and let's do the same with this one. So once I have this, should be installed. I have installed my 2 packages here. I have Microsoft ML and Microsoft ML time series. And let's try to do the same that I just did in Excel, but with a couple of lines of code. So let's go back here, project number 4, set a startup project. Let's add the Excel file. I am going to use the same file, setting item, test, sorry. And here in data samples, I want to do anomaly detection. So here, what I am going to add, I'm going to add the Excel file, and I already created the product sales data in order to automate this, I don't want to add here the classes. So I have everything here. Final check is, let's copy the file there, and let's go back to the program to start to do our anomaly detector. So again, first step will be, let's create a context. So I'm using, I will define the chunk of that I'm going to use. In the Excel file, we have 36 rows. Yes, 37 here. So with the headers, it's 36. That's kind of what we want. So I have here my size. Let me show you why I'm using the size. So let's do the ABC. Let's load the data that we have here. Again, very simple, load from file, CSV, and we create a list of data, and we are going to create an empty data view here because I want to create a predictor based on an empty of this product sales data. By the way, the product sales data has the two fields that are already in the CSV, the month and the num sales, so nothing fancy here. And the next step will be, let's create an estimator and build the model. So let me do the full step here so you can take a look of what we are doing. So let me predict this. So I am going to use here another, I'm not going to use a binary classification or a multi-class. This is a transform directly that is going to detect spikes. And this is based on, I can share the links later. This is based on a specific algorithm to detect spikes. It's going to detect with all of the data, and it's going to generate a pattern, and then it's going to detect the spikes around this pattern. And everything that is, we can define the spike, the pattern, and then we say everything that is, I don't know, 15% out of the boundaries of this pattern is going to be considered as an anomaly. So here, we are going to define which are the values, the fields that I'm going to use, which is going to be the prediction with the sales. And then I'm going to say, you know what? 95% is good for me. So everything out of this 5% is going to be considered an anomaly. And then what I am going to do is I'm going to analyze this on chunks. And the size of the chunks is going to be 36 divided by 4, which is going to be 9. So every 9 lines is going to generate a subset to create the pattern. I can do this. You need to have at least 3 chunks here. So I can do this divided by 3, but with 4 is the best one. Then I'm going to train the model. I already have my model here using the empty data view because it's going to be trained without data. And then I am going to transform the model using the original set of data, my Excel file, and I am going to create my predictions. And let me show you how to show the predictions. So you can take a look and see how this makes sense. Once I have my predictions, I am going to start to analyze the prediction. I am going to put here, let's add a break here. And I'm going to put here a breakpoint. And what I am going to do, I'm going to start to analyze the predictions. Each one of the predictions is going to have a vector of 3 numbers. And the first numbers is going to be, this is an anomaly, yes, no. And the second and third is going to be the current value and the expected value to be there. So let's run this. Let's see how it works. I think I am missing some action in the chat view. I am going to be back there soon. So it's building. Yes, there it is. This is faster. Small data set. Doesn't require a lot of memory. It's already transformed. It's already there. So I have here my predictions. The predictions are a big array of numbers. Each one of the numbers of vectors, I'm sorry. Each one of the numbers has a prediction to false. And what I have here is for each one of these, if the prediction is 1, it's going to be an anomaly. And if not, it's going to be a different one. And remember that what I have here in each one of the elements is I have the prediction true false, the value, and how far it is from the to be considered as an anomaly. So if I run this until I get an anomaly, take a look that the third value is so small that is because it's so far away that is considered an anomaly. So let's take a look at the final result in the console. This is my console. And this value, 426, is considered a prediction. The same one, 580, and with 687. If I go back to my Excel file And then let's do this one here. And then start to look at the chart. Let's minimize the chart a little. Sorry about that. This is the problem when you get used to work with big monitors, that later is hard to share to switch to presentation mode. But 426, this is 426 for sure. We can take the value there, is 426.6. So this is the value that is considered an anomaly. And the second is 580, which is probably this one. Yes. And 685, which is probably that one. So that was considered an anomaly, all of these. Again, if we take a look, these, and these make kind of sense to be considered anomalies. Somehow, I was thinking that this one and this one were, no, I'm sorry, not this one. The second one is going to be considered an anomaly, but I didn't need to do anything. I mean, I can be wrong here, but I can have here my machine learning.net scenario that is going to give me the chance to understand, hey, this is the one that they have. And if I go here and I change the confidence, instead of 95, I go here for, I don't know, let's go for a lower one. And let's delete all of the breakpoint for 65. And I run this, a lot of others dots are going to be considered. A lot is going to be considered. A lot of being considered anomalies because my threshold right now is smaller. So everything outside of this threshold is going to be considered an anomaly. So I am not going to do the comparison like before, but here, basically every big spike is going to be considered an anomaly. So again, it's for us. We need to figure out which are the values that we want to use that are going to fit into our scenario. But it's very easy to do. It's very easy to understand. It's something that we can easily get here and start to play around and start to see, hey, where I am, what I am doing. If I change also the size, I can have different values. That's not the idea today, but take a look of what we have. And remember that I told you that there are plenty of scenarios that are covering. So if you go for machinelearning.net, you are going to find a lot of documentation. You're going to find a 101 video series, amazing 10-minute tutorials, a very good description of what is machine learning, how you can go into use. You have the 101 video series. What I really like, besides all of this documentation, by the way, the documentation of machinelearning.net, it's freaking amazing. You have here, and I'm sorry, I know that when we are presenting, I'm supposed to use white themes. It's not easy to read here, but there is a lot of documentation here, which is really great to use. What I personally like to do is go to this repo. Remember that I told you there are two repos, the machinelearning.net repo and the machine learning samples repo. I like to go to this repository and start to figure out and start to play around and start to see, okay, which are the scenarios that I have covered today? So I have binary classification scenarios. I have multi-class classification scenarios, recommendations, regressions, time series forecasting, and plenty of other scenarios. If I go at any of these scenarios, if I go to an example to the clustering, to the C#, each one of these scenarios has a demo application. All of them are in C#. Some of them are also in F#, and you have complete application here. So I think one of the image ones has a website that you can upload an image and do the classification. But here an example, this is using the previous version, the 1.4, but this is the clustering iris. So this is a clustering scenario. So what we want to do, this is the problem. So you have a problem description. You have the machine learning task that you are using there. This is the explanation of why we are doing A, B, or C. And this is how is the solution implemented, how you can build the model, with how are the paths that you are doing. So in example, this one is not using typed class that I've been using. This is dynamically defining the columns that you want to do, that you want to use, I'm sorry. And then how you train the model, how you consume the model, and that's it. And all of the scenarios that are available here have the same, let me pick up. Oh, at the bottom is the cross-cutting scenarios where you can take a look at the full implemented application, a Razor web app. Hey, a Razor, amazing. that you can start to use. And again, you can use this as an inspiration for your own scenarios, starting to play around, change things. And I will play my no. I am reading the chat. Sorry for the pause here. I'm reading the chat here. I will play my non-English speaker card to not bluff off the joke, the cross-cutting concerns. But yes, this is cross-cutting scenario. And at the bottom, I will talk about machinelearning.net here. You have the contribution guide, and you have the chance to request an issue. I upload a couple of issues here. I put something else, but this is an amazing place to start because, as I said, what I want to do, I don't know, a recommendation of products because I have products and I have client history, how I recommend products. I can go here to this one, product recommendation, start to see how we are going to do this. So it's using the preview of the 0.16. I think this is an old one, but this is an example of the problem, the data set that we're using, the algorithm that we're using, the matrix factorization, and a lot of other things that you can do. So the documentation behind machine learning.net, it's also amazing. You have the standard documentation where you're going to see, in example, how you choose an algorithm, what you want to do, which is the definition of a task, what are the algorithm, how you define your algorithm, or you can also do, oops, not this one, or you can see which are the tasks here, how you evaluate your metrics. So there is a lot of official docs, but you also have the repo where you can really see implementations, and I really, really like this one. So this is kind of the core of machinelearning.net. So once you have this, oh yes, I just realized that your website is crosscuttingconcerns.com. Hey, here it is. You can add your own example here. I'm sorry, Matthew, I haven't realized that. I just see in your profile view that bio that you have there. But let me go back here. I told how this is kind of nice. This is kind of great. This is it. This is what we have. This is the place that I will do the joke. Probably a couple of you knows how you do this. There is something wrong in this image. You can figure out a couple of, I will wait, drink some water and see if someone already knows there is something wrong in this picture. I don't know if you can spot it. Yes, there is a panda here. You are right. So when we are doing anomaly detection, we can use Excel. Excel is fine, but sometimes we need to automate this because it's not easy to find this panda here. You can spend a lot of time, but the machine learning view algorithm can do this in less than a second. It's freaking fast. And yes, it's kind of a fifth lore here. I won't get to Star Wars. I don't want to make this Star Wars, but going back to the beginning, this is the ABC of machine learning, as I told. We usually spend 80% of our time preparing the data, cleaning the data, trying to figure out if the data makes sense or not, trying to figure out if we don't have any kind of biased data, making some very, very format and impulse in one way instead of the other. But what's happening when you need to train your model? What happens when you need to figure out what to do? The ABC say that, hey, I have here, I will train my data. I want to have this unicorn, so I will do some machine learning when to have the unicorn. Sadly for us, at the beginning, when you start here, this is what you get. It's not a unicorn. It's going to be, this is a crappy, I think this is Exploding Kittens or one of the game cars that we play with our kids. But we're going to have a crappy pig with a horn there. It's very, very hard to start with machine learning because it's hard to clean the data. It's hard to choose the algorithm. There are a lot of complicated parts that we as developers are hard to understand. So this is the moment that we can use these extra tools that are part of machinelearning.net to get there. So Piggycorn, yes, that's the name. Piggycorn, I can't remember. I need to bring my little daughter here. She knows the name. She is the one that suggests me to do this. So there are two tools that we can use on top of that as a developer to help us basically avoid all of the things that I've been doing and do this in 3 clicks. So one of these is AutoML. AutoML, when we are training models, one of the key things training models is how I tweak this confidence from 95 to 65, how well is my model working when I do this A/B, what's happening if I use this trainer or I want to use this other trainer. So everything that tweaking this, playing around with these parameters is a mess. We spend a lot of time here. AutoML is a tool, and there are different flavors of this. There are different tools to do this. Machine Learning.net have one that allows us to basically get out from there, and this is going to do all of the work for us. So in example, I live in Burlington, Ontario, in Canada, and let's think that I want to solve a simple scenario, which is how much I have an historical data set with tons of data with Uber trips and when we used to use Uber and taxis now these days. But if I want to solve the question is how much is the taxi fare going to be for me from Burlington to Toronto? I want to make that prediction. So what I'm usually going to do, I will train a model using machine learning.net to basically all of this historic data to make prediction around the taxi fare, how much it's going to cost. So I have all of these features. I have a couple of algorithms to choose. I have parameters. So I will start to make my test. So I will choose, in example, the first run, I will choose distance, car type, and passengers. Then I will choose one algorithm, the gradient boosted. And from the parameters, I will apply these values in these parameters. And I will have a model. And the final accuracy of the model is going to be 30%. Not good at all. So I will change this. I will add a new feature. I will add the trip time. I will use a different algorithm, change the parameter for this algorithm, and I have a better one, which is 50%. But I need to do a lot of test and try in order to get to a decent model. And when I try this in example 15 times, okay, my best model was the 95 one, so let's use that one. This took a lot of time because you need to play around with different models, with different algorithms. I'm sorry, not model, with different algorithm. You need to tweak the parameters. So this is the moment that machine learning.net AutoML makes sense, because what we are going to do is we're going to use this AutoML and we are going to say, hey, you know what? I want to do a prediction. I have this data and I have this constraint. AutoML is going to start to play around. It's going to start to try all of these elements here, and it's going to say to me at the end, hey, I tested these 5 different algorithms with these parameters. Option is one of them, and this is the best model. Or if you have more time, just put this to run all night or a couple of days, and I will say, I tested 1,500 different combinations, and this is the best one. So it's going to do all of the work for us. And another cool things about AutoML, it's also, remember when someone asked, how do we know why a model is giving me this result and not this result? What I know also here is when I have the output of this model in AutoML, I also know in this model that this model used in example model A was very, very heavy on the use of the field's distance and time of the day. And the model B, which has a less accuracy, has a bigger use of the trip time. So if somehow my scenario requires, I don't know, for my scenario, the trip time is more important, I may want to use the model B. So somehow I understand why this is happening. And the way to do this, there are 2 ways to do this. One of the ways is we can do this using code. We can, let me show, oh my God. Sorry about that. I don't think you're going to be able to read this. Somehow when I paste this in this format, the text was ugly font color, but it's going to be the ABC. I'm going to load the data. I'm going to start an AutoML program. You need to trust me. I'm going to show you in Visual Studio later. It's going to be much more human decent. Run the experiment, and at the end of the experiment, I'm going to have the outputs. But there is another way to do this, which involves Model Builder. And Model Builder is an extension that we have in Visual Studio 2019 and 2019 preview. I think it's also available in 2017. I don't know. It used to be available, but I don't know. But this extension is going to be kind of a wizard, a visual wizard, that would allow us to do this. So you can see here, this is the one that I have installed. I have the Model Builder preview. still in preview this. I have also the model build the GPU because I have a good GPU, so I want to use my GPU here, and I can use this right now. And the way to do this is very simple. I can go to a project here. I can add a new item to a project, and you see here that in new items, I have a new type of item, which is machine learning. So this is the one that I'm going to use. I am going to create a new machine learning element in my project. Sorry about that. I miss it. Machine learning. Once I add machine learning, I have different type of scenarios that I can do. So I can do text classification, value predictions, image classification, recommendation, or object detections. And I have a couple of other scenarios on the go. Remember, this is in preview, so they are adding new scenarios on request that I can start to use here. And the cool thing about this in example, and I'm going to show you an example later, is that for the heavy ones, remember that everything image-based requires a lot of processor time. When I do an image scenario, I can say, hey, you know what? I can use my CPU. I have here an Intel i7. I have almost 49 gigabytes of RAM. I can use my GPU. I have an old NVIDIA, but I can use my GPU. When I did test, this is 4 times faster. Or I can even use Azure. This is going to train a model using the cloud. So if you have your credit card and you are happy with this, and you are using a lot of data, you can go here and use Azure as a training model. I will do everything locally because I will go back to the sentiment analysis and I will do a text classification scenario. So text classification, right now, the only support CPU. And what I am going to do is I'm going to define where is going to be my data. And I can load my data for this wizard using a file, or I can connect to a SQL server. SQL server locally on the cloud or whatever we want. I have my file here, so let me go to my file. Let me go here, share it. Let's pick up the big one. So I have the big file here. So once I have the file, it's going to load the file and it's going to ask me for, remember that in this specific scenario, I need to define features and labels, inputs and outputs. So I'm going to predict the label column, and I am going to use as input columns the one that I want. So I'm going to say, remember that we have several columns here. I can use the comment, the year. I only want the comment. And I have here small preview of what we have. This is kind of the visual step that we did before, but there is a trick here. I will train this model, and it will suggest me that to train this model, I need to spend at least 10 minutes. We don't have 10 minutes here. I don't want to have you 10 minutes looking at my screen. So I will use 1 minute. Because I'm using 1 minute, Model Builder is kind enough, thank you Microsoft for this, to say, hey, you know what? You're using a big file here, 17 megabytes. So for this file, we suggest you to spend at least 10 minutes. So it's going to give me a couple of recommendations. I am not going to do this. I am going to continue anyway. So start training. And this is the important part. When you start training, what we are going to start to see, and I hope that 60 seconds is good enough. It used to be good enough. I hope in this version it's still good enough. We are going to start to see in the output how Model Builder is training and testing different type of algorithms and trainers and give me values around this. So at the end, it will probably train and use 2 or 3, and it will choose the best of these 2 or 3, and I will have the chance to review this and use the best one. So this is my 20 seconds to read the chat and to see if, okay, it trained one with a trained using the average perception OBA. The accuracy is 95%, so this is a good one. Let's see if we can have a second one. I hope so. Okay, just one. So let me do this. Let's train this using 2 seconds. So it's finalizing the model. It's only explore one model. So let's cancel. Let's cancel the training and start again. I want to show you how it shows 2 model. At least, yes, so 10 seconds. At least 2 different trainers, how we use 2 different trainers and how we get the best in each one of these so we can have a sense. So in this one, I will use 2 minutes. Good time to go back to the chat and start to read the questions. I see the pandas. I see the words. Sorry about that. I was supposed to have this. I don't know why it changed the format. It's supposed to be a good format, but this is kind of the idea. And by the way, remember that one of the scenarios was giving me the chance to train to do image recognition, which is kind of amazing. This is the output while this is training. We always have to have a plan B when we are doing demos. We never know what's going to happen. So I train one scenario. I have here a set of pictures, an amazing set of pictures, by the way. This is the picture that I have. I have drawing here with fish. I have flower here, all drawings. And then I have humans, again, all drawing. So I choose these files. Oh, I have the files here, I'm sorry. I choose this folder with files sorted in different other folders, and I train a model. And when I train the model, it took almost 5 minutes. And when I have the model, I can test this model. And again, this is an ABC to train this model. So let's open Paint, and there's Paint, yes. Let's change the size. Let's draw something using the mouse, which is always very amazing. So this is going to be an angry fish for CONDG. Sorry about my drawing skills. And let me save this in my desktop, like as fishy. So I will save this picture, and let's make a prediction. I have here my model, so I can go here and go to the desktop, pick up the fishy, and if we are lucky, it's going to say that we have a fish here. Let's see what is happening, how it's doing. Oh my God, demo mode. And by the way, the output of this model when it was generated was 81%. So it's kind of a decent one. And it should be fast. I don't know why this is not working here. I generate this before we started oh, there it is. So it's 65% that is sure that it's a fish. It's kind of decent, but it's also sure, it's also have some chance that this is a flower or a human. If I go here, I generate new one. Let me try to draw a happy human. So let's go for the human. Let's try with the human face. It should be faster. It's already loaded in memory. So let's take a look. So yes, this is a human 100%. And the output for this generation, as I told you before, is not going to be just toxic or not toxic. In this scenario, I have 3 possible results. So I have percentage in each one of them. If I draw something that doesn't make sense, like this, in example, doesn't make sense, and I try this, I will still have these values. I will still have the value, but I will probably somehow, this is closer to a flower. It's 81% sure this is a flower, and it's not a flower at all. So I need to train my model and use this as a not example of do this. So yes, no, I didn't draw this. I mean, for another machine learning, I am reading the chat here. For another machine learning demo that we used to do in the Ignite the Tour a couple of years ago or something like this, I have this set of data. They are very bad. They are very funny, but it's good enough to see how this works. And also, we have fishes in 2 directions. So if I go here in an example, create a new fish in the other direction, and I don't know why I like to add faces to fishes. It's also recognized as a fish. So I will do say fish 2. I go here, go to evaluate, try another image, fish 2. It should be a fish, I hope so. And by the way, the way that this is doing this is, yes, this is 90%. This is even better fish than the first one. So it's downloading an already image recognition model trained with TensorFlow. It's called the DNS ResNet 50. And it's doing transfer learning, a technique, which is basically using all of the steps that this model has to detect a specific set of images, is going to adapt these steps to train using these images. But hey, this is another of the scenarios that we can do with this. So let's go back to the other. Let's go back to the other scenario. And oh, yes, okay. So we have a little more here. So in this one, it trained using, I don't have Zoom here, oh my God. It trained two different models, I'm sorry, should be, I probably need to pick a smaller file, but from these two is going to pick up the better one. And the better one in this case is the SDCA. So once it generates this model, it's going to analyze the accuracy, is going to do this, the work for me. At the end, if you want to do this, you need to have this up and running for a couple of hours, and you are going to have a full list here of model trained and the result of the models, so you can see how well they perform. And then it's going to basically be back to us to understand what we are doing. The cool thing about this is once we train the model, what we can do is take a look here. The best result here is a 95% accuracy model, SDCA. I leave this up and running for a long time, and the best one was the one that I was using in the demo, the SDCA logistic regression, I think it was. But the idea here is that once we train this using Model Builder, we don't need to go back and I really hate this comment. We don't need to go back and do the same in our code and train the model. We can reuse this, or we can even test this. Like I say, it's a decent movie. So if I do a prediction with here, it's going to say that the model is going to be not toxic because it's going to be kind of fun. It's a crappy movie and it sucks. Let's stick of what we know. It's going to do a prediction again, and it's going to be toxic for sure. So this is kind of how we can use it. But the cool thing is at the end, what we can do is we can consume the model. So the model is trained, the model is generated, and the next step, if I do this, is going to basically add two projects to my to my solution. One of the projects is going to have the model, and it's going to have the steps to train the model. So the only thing that I need to do is drop a new data file, and it's going to train the model again. Oh my God, stop responding, come on. There it is. So I have one project where I can see the model. This is the generated model here. And then I have the input and the output. So the input with all of the files, with all of the fields. We don't need all of the fields, but I have all of the fields here. The output, very similar to the one that I used in the first demo. And then I have here the consume model that is going to say, hey, you know what? You can load the model here. You can create a predict engine, and you can do the prediction. It's doing this. And also to train the model. So this one is going to pick up, is going to run the process again, is going to pick up the initial file, is going to create a data view, create an estimator, and do all of the steps that I copy and paste in the PowerPoint and basically kill the format. This is all here, and this is the one that at the end is going to give us the best estimator, the best one. So the model builder is an amazing option in order to, hey, I want to train a model. I know my scenario is here. I'm not sure what is the trainer that I want to use, but this will give us a sense of this is the best trainer. This is also a good one. So as a developer, you start to get used to these names and terminology, and you can get here and use, you can get here and start to use all of these. Finally, in order to use this, remember that the scenarios that we have here are one for text classification, other for value prediction, image classification, recommendations, object detection. This one is, you need to set up a workspace in Azure. It's only runs in Azure. I already have, let me see if I have my account here created. Yes. I think I have here a couple of accounts. I have a compute. This is going to run here and use my compute in the Azure. The main issue here for this one is that you need to create a JSON file that is going to basically define for all of these images what are the steps that you need to do in order to, in this image you have this box here which is a dog and this box here which is a cat or whatever. So there are different ways to do this. We can do the same with this one. If I go to Azure and I set up the workspace and do the same that I just did with the images. Okay. Choose machinelearning.net, yes, the compute. I am going to create a new one. And the important thing here is that, let me go to next step. Let me pick up my images. See, machinelearning.net. Here it is, next step, start training. The first thing that is going to do is going to upload the images to the cloud. So here it's basically creating a resource, a blob storage, uploading the images, and then it's going to start the monitoring. The nice things about this is that everything that is happening here, I don't know where it's opening this one. Let's click again. I think it's going to be in this one. Yes. Everything that is happening here is going to be part of the machine learning portal. So I will be able to track in real time how it is working and how it is using. I can spend here another 15 or 20 minutes talking about machine learning on the cloud. This is not the idea. I will be happy to cover this. The important piece here is that I am using this compute in machine learning in the cloud. You have different computes. You have different elements here. And basically, these computes are machines that you have defined, virtual machines that you have defined to train. And you can use something amazing like a GPU. And then you have here standard GPUs with 2 Tesla NVIDIAs for this, or very expensive one with 4 Tesla PK or 4 Tesla P40. Crazy ones. Get ready for your credit card to be used here, but you can do a lot of things. This is the cheapest one that I am using just for testing, and it has kind of a nice configuration here when I can see 6 cores, 56 megabytes or gigabytes of RAM, and then a GPU, a decent GPU. If I go back to my experiments, I can see here that it's running one experiment right now. Let's see, this is the ones for today. So this is 24th, yes. So this is there is one more here. No, I don't want this one. So this is the one that created today. And there are 4 because one of them is kind of orchestrating the other is working with the data, other is doing the training. And it took, even if it's only 8 images, it took a lot of time because putting all of pieces together. But hey, you are training this on the cloud, and we can see a lot of amazing things here around this. So I want to give some time to Q&A. I want to yes, Integer Max says that this stuff have come a long way. Yes, the machinelearning.net team is amazing. They are doing a lot of things. As an example, training a model on the cloud was one of the key features that a lot of people were asking, because we have machine at home, we love our machine at homes, but I don't want to copy my code into a virtual machine on the cloud and then reproduce the code there. Hey, if I can go to Model Builder and say train on the cloud, that's a huge goal for us. Oh my God, one failed. Which one? Oh, no, they are still running. I'm sorry. This is the full view here. So let me go back to my slides. As I said, we are at the end. Let's move here, AutoML. There it is. So to close the story, where we are, remember my cat. Remember that I want to use the cat. I don't know if the animation is going to see this well or not, but we trained a model with my daughter. That's my daughter. And you see the cameras that we have here in the basement where the cat is eating. What we have is add these cameras to detect the cat. So when the cat is moving, you are going to see a frame around the cat. Yes, that's my cat. And hey, I am still not tracking. We are still not tracking if the cat has some mice or a squirrel or whatever, or a little bird, but I already track the cat. So I can know when the cat gets in and out of the house. So maybe I need to check those frames to see if there is something else there. I am going to share everything later in my blog. I am going to share everything with Matthew. This is kind of the main links, and someone already shared the .NET/ML. This is where it starts, but then you can take a look. I will strongly advise to go and take a look of the samples. If you have some data, that you want to play around, maybe you can fit this data to one of the samples, but then it's the documentation. You can contribute here. There are plenty of other things to do, and that's what's basically it. This is, if you want to have contact with me, this is my Twitter, bottom left corner, @elbruno. This is where you can find me and all the places. In my blog is @elbruno, GitHub is @elbruno. I will share everything. And hey, I will start to read the chat to see if we have any question. Matthew, I don't know if there is something else before we start the Q&A that we need to do, but that's basically it. I try to have some late 20 minutes to do some Q&A.
Well, thank you very much, Bruno. I appreciate the extra content you've given us. It's very nice. And I think there's a question there from Integer Man, which is about debugging options for visualizing or debugging machine learning scenarios when the results aren't what you predict.
That's a good one. So, and that's sometimes remember when I did the unicorn and the crappy pig? This is the ABC of machine learning. Sometimes you have your data. You are so sure that with this data and these trainers, you are going to have these results, and it doesn't work. It doesn't work. You have crappy results and you don't know why, and your accuracy is low. So that's the moment you have two options. You can go back and start to try to go deep and learn on what is the algorithm that you are doing, how you can improve this, how you can improve that. Most of the time, I will, and this is personal experience, I will start to play around with a smaller set of data, different trainers, and maybe something with AutoML. Maybe you need to do the AutoML, and the AutoML will suggest a different algorithm. So, hey, maybe it's not the best one, but the second best one is the one that you want to use. So that's kind of another option.
Okay, great. And normally at this point, we would all give you a round of applause. And so if you want to do that, just put some emotes there in the channel, or just say the word applause. And thank Bruno very much for his presentation. Very good. I'll give a little bit of a clap here into the microphone. Thank you very much, Bruno. I appreciate the presentation. And so if you have more questions, Integer Man has been clapping for the last 15 minutes. So his hands got to be sore at this point. But no, we couldn't hear you, Integer Man, so you got to clap louder next time. We got some more thank yous, some more claps there in the channel. All right, very good. Thank you, everybody. All right.
So thanks to you, Sam, for the invitation. And again, anyone have a question or whatever, feel free to contact me. And if you already give a try last year to machinelearning.net, go back today, because it's really, really, really advanced. There are plenty of things to do. And the product team, and I am biased because I know those guys, they are amazing. They are looking forward to see what's next, what else we can do in order to help you. So, hey, you don't have the chance to ask and give so often, so let's use this one.
All right. So at this point, I think we're all wrapped up here. If there's any more questions, what I want to do next is actually kick off the raffle drawing, if that's okay. And so, Bruno, you're still on the screen here. You're still, if you don't mind, hang around for a second here, and
yes,
we'll do the raffle drawing. So just as a reminder, today's raffle, I'm going to bring this over here on the screen here. Our first place prize is a JetBrains license. So, of course, ReSharper is always a good choice, but there's other great stuff out there, like for Ruby, for JavaScript, for PHP, etc. Any of those things are available with this license here. I will email this directly to you. You got to be present to win, but make sure to get a message into the chat right now, into the Twitch chat right now, if you want to get entered to win. So all you got to do is throw in a message there in the chat, and you'll be entered. Even if you've already done it earlier today, just do it again, just to make sure that you're in the database there. The second place prize is just a package of Couchbase stuff. I'm going tape up into a box and slap a label onto and send it to you. You must be in the United States to win that. Okay, so once I actually do the drawing here, let me bring over my Couchbase console for the drawing. You must be present to win, like I mentioned. And I'm just going to write a SQL query here that will pick somebody at random from today's chat messages. So they're all being stored in Couchbase. And it's a select query, order by random here, as you can see, and limit 1. So we're going to pick the second place prize winner first. It's going to be a Couchbase swag. So lots of stickers. I think I might have maybe a water bottle, a t-shirt or something. And I'll throw that all together there into a package and send it your way. Must be in the United States, please, to get that prize. So let's go with that one first. Drum roll, please. Winner is Sean W.A. Sean W.A. Are you still around, Sean W.A.? Sean _ W.A. Just say hello in the chat if you're still around. Please, Sean W.A. Sean W.A. going once. Not seeing any messages there from Sean. Let me zoom in a little bit here so this can be a little larger. Going twice for Sean W.A. Sean Washington, I assume. Or maybe Sean Wapakoneta if we're talking Ohio. Okay, going twice. Sean, sorry, you are not winning this Couchbase swag. Okay, we'll hit execute again. Drum roll, please. The winner is Dtran2211. Dtran2211. Are you in the chat? Dtran2211. Please say hello if you're there. All right, congratulations, Dtran. Would you please, you can either whisper to me or email, that's me at mgroves.com, your home address, and I will get this shipped off to you. By any chance, Dtran, while I have your attention, do you wear a size large t-shirt? Because that's all I have right now, a size large. So let me know if you have if you can wear a size large. I'll throw a t-shirt in. Otherwise, I'll throw in something else. I've got some other cool stuff I can throw in there. Size large is fine. Okay. You're getting a t-shirt, Dtran. All right. And now for the first place prize. This is the JetBrains license. So drum roll, please. The winner is me. Again, 2 months in a row. I'm good. I already have JetBrains licenses. Yeah, as a feature. You notice there's no extra weight in here for Matthew D. Grove, so it's just completely the random number generator working against me. All right, we're going to try it again. Execute, and the winner is JW8686. JW8686. Are you still hanging around? JW8686. John Wayne 8686. Are you still there? Or is it Juliet's Whiskey? Juliet Whiskey 86. Hey, all right, JW8686 here. Congratulations, JW. So all you need to do, JW, is either whisper or email me your email address. I don't need your home address. You can whisper or email it to me, and I will get this JetBrains license off to you. All right, congratulations, everybody. And now's your last chance to get in a question for Bruno, as I say thank you one last time to Bruno Capuano. Is that the correct way to say it? Capuano?
Yes, it's Italian, so...
I see. Like when the swallows come back no, that's Capistrano. Sorry, that's Capistrano, not Capuano. Sorry. So Bruno, thank you very much for the presentation. And as I understand it, you will make the slides and code samples available. Is that correct?
Yes, I will share everything in my blog and let me know where do you want also. I will be happy to share.
You can send me those links. I'm just going to leave them as comments in the meetup link today. So if everybody following along, if you go to condig.org, you'll get to the meetup site there. And when I get around to posting this video to YouTube, they'll also be linked there. So make sure to check both of those places. And that's it. So any more questions for Bruno or any other parting comments, Bruno, before we shut down the meetup for today? Thank you very much, Integer Man. Yes, I do miss the in-person meetings as well. We don't have any plans at this time of going back to in-person. But we'll let you know when and if we do. You'll think of questions later when trying to sleep. That's okay. So you've got Bruno's information. You can always reach out to him on Twitter or whatever. I personally want to use some of this stuff to help organize my family photo collection. I've got 25,000 plus photos, and I really need to figure out like which photos are good, who's in the photos, and stuff like that. So I might try to use some of this stuff for that. Lightweight, 25,000 is a lightweight? Okay, maybe. I think it's quite a lot. It's way more than my parents and my grandparents have, that's for sure, of their families. Because everyone has a camera in their pocket now. Okay, well, Bruno, I'm going to let you go here. I'm going to take you off the screen if you don't mind. Thank you
Okay.
very much again. And thank you, everybody, for coming to CONDG. I appreciate it. So make sure to look for more information on CONDG on Twitter, on Meetup, on Facebook, on YouTube. So thank you very much for joining. I appreciate it. I hope everyone has a good night, and we'll see you next month for October's Meetup. All right, everybody have a good day. I'm going to put some trivia on just to kind of play us out.